here's today's agenda. We're going to be, first of all, talking a little bit about AI across the software development lifecycle. This is more of an industry-wide look to see how is the AI impacting things. Then we're going to look at some of the AI we've introduced recently into the Inflectra product lineup. And then we're going to look at some of the functionality that's coming in the days, weeks, and months ahead. And then I'll take your questions. So let's get started. First of all, just a little bit about me. It's not about me, it's about the AI, but just to show you, my name is Adam Sam, and as Rick mentioned, I'm the founder and CEO of Inflectra. I've actually been a software developer since the age of 10, which was a while ago. But one thing that's interesting, just to note, is that when I was in high school in the United Kingdom, we were one of the first classes to have a talk on AI. This is back in the, I guess, 90s, late 80s, early 90s. And they had a class on AI. It was based on the Prolog programming language and various different interfaces that were being developed. And it was going to be round the corner. Of course, 20 or 30 years later, now it finally is. So I feel like I've come full circle. I was learning about AI when I was about 12 to suddenly being in this industry, which is right now changing really rapidly, which is very exciting. So hopefully we can take you on that journey, answer your questions, and get excited about what AI is going to do for us. Now, one thing, as a public safety announcement, Gen AI and AI in general is improving daily. There are new models, new capabilities, and new use cases. We're going to scratch the surface today, and everything we talk about today is probably obsolete within an hour or two, if not a week or two or a month or two. So just know that, and that's okay. Let's talk about software development, though. AI is obviously impacting the universe and the world in a broad sense, but how is it affecting software development? Well, we're all familiar, I think, with the DevOps infinity loop, where you plan software, create it, verify it, package it, release it, configure it, monitor it, deploy it, and then plan the next version and so on. And with the move towards continuous integration, continuous delivery, agile, and DevOps, this is how we release software in an ever faster loop. So one of the things people always ask me is when I'm at a conference or a trade show would be, where is AI going to impacting? Is it going to be focusing a lot on the development? Is it on the user experience? Is it on monitoring? And the answer is, it's actually everywhere. And in fact, if you think about some of the use cases you've probably heard about in the news, when you're looking to plan software and design it and define it, there are tools out there right now that can listen to, or rather watch a video of someone using something, and from a usability standpoint, can determine based on that video what functionality needs to change, what new screens need to be developed, how the UX should improve. So classic, UX design, user research, AI is being used to help improve the speed and the accuracy of that kind of activity. When it comes to building a new piece of software, people have talked about the idea that you could draw a screen on a napkin and give it to AI and come back after the coffee, you've got an application. Now, it's not quite that level, but certainly you can give a design to an AI end model, and it can generate some code to give you a rough prototype of that screen. And if you think about in the early days of rapid application development and agile, often you would take a design with a customer, you'd want to be able to show them something and do an MVP. Well, I mean, AI can generate these MVPs really quickly. So in terms of rapid, fast prototyping and feedback, AI is already changing how we do that. Obviously, we're going to talk a lot about testing, so I won't steal the thunder of this presentation by going too much into the testing side and the verification. Deployments, AI is helping people do deployments and manage deployments, assess risk, monitoring functionality to monitor and do telemetry, and also be able to be embedded into systems to track systems in production, see where there are issues on the shift and right side of things. So AI is really in that entire infinity loop, improving efficiency. Now, in terms of the testing side of things and quality, how is AI changing that? Well, it's changing in very different ways, both positively and negatively. The first thing we're going to see, and we are seeing already, is that testing was always the bottleneck, and that isn't changing. So if you think about a software development team, you've got developers, designers, you've got testers, you've got people on a typical agile team. And some of these models, like these GPT models, is able to increase the volume of development. And so whereas in the past, for example, if you think about software development, where do you get your code from? So if I'm a developer, and I actually was a developer, not a tester, when I'm going to create a new screen in, say, one of our applications or another application, the first thing I would normally do is find the screen nearest copy it, and then change it, right? I don't typically, that's just a brand new application. And even then, I don't necessarily take a brand new piece of a page, write code from scratch, I'll find an application that's similar and I'll start to use it. So we typically use pattern matching. We use existing boilerplate that we've done before, or we take the example that worked for us the last time, or we go on GitHub or Stack Overflow and we find examples that are close to our use case. We don't typically write every line of code from scratch on a blank sheet. And so if that's the way software development has always been done, AI is basically taking that exact same concept and just accelerating it massively. So whereas before I would go on Stack Overflow and my last project and cobble together some code that kind of worked and hope that would be a good first pass at my page, then refine it. With AI, you can say, I want a page that does these things, build it for me, and then you refine it. And it's just much faster. And so one of the limitations has been the refining takes longer, the verification takes longer, but the generation is getting faster. So we're now able to write more code than ever before. And what does that mean? Well, it means that we're actually going to need more testing. So there's more testing and verification and quality management, because as you start to increase the volume going into your process, you therefore need to improve the verification speed. So an analogy would be, if you think about software development, it really has been a craft industry. We hire people out of college or experienced people to manage them, and we put together a team. We define requirements, and they obviously write the software. But it's been kind of a craft industry where people on their screens are writing code and reviewing it. If you look at sort of the manufacturing world, it's as if we were all making stuff in a craft manner with our own set of tools, building it and assembling it. Whereas with AI, effectively what we were doing is we're turning it into more of an assembly line, where machines like robots assemble cars, robots work in factories. That's the way manufacturing has evolved. Software is essentially evolving in the same way. And instead of me writing a bunch of code which someone reviews, computers are going to generate a lot of the boilerplate code. I'm going to tune it, I'm going to verify it, and I'm going to supervise it. And so it's like a factory. I'll be a supervisor. I won't be a someone who's taking a hammer and tools and putting together a car. I'm going to be watching the car going along the assembly line and making sure that the wheels are put on properly. It's the exact same thing. So I think the volume of testing will change and the type of testing we're changing. So the responsibility will be on the checker more than the programmer. So the other thing is with AI, who's writing the code, who's responsible when the bugs are found, it's a much more difficult decision. It's not simply you can go back to the developer and say, you wrote bad code, fix it. AI has generated code that's 95% accurate. We've got to tune it. We've got to test it. It's a much more collaborative process between the development team and the testing team, basically becoming more checking and less doing. It's more heuristic. And so if you think about a typical skill profile, it may be more left brain and more right brain. Now, when it comes to what are really important skills, and people always care about this a lot, because when I go to a testing conference, one of the questions tends to be, will I still have a job? And if so, what will that job be? And I think the answer is, as a tester, particularly, but even as a developer, your job will change. The days of just churning out lots and lots of code, the days of writing large amounts of Selenium scripts, perhaps in rote, those jobs may well disappear or certainly become less common. And using your skills to better develop tests, analyze code, develop architecture, those higher level types of skill will become more important. So I think it will change how we do our jobs. And so that means that testers who may have felt that without programming skills, without becoming an SDET, SDET, they're not a value tester, that may change the other direction a little bit. Because if programming is going to become more commoditized, testers who understand business applications, understand risks, understand how to document the application, how to write manuals for it, those people will be in higher demand, because the reality is that's what's going to be the value add, and a lot of the other stuff will be automated. So it's going to change the balance of skills. It's going to change how you do your job. But we'll need more testers and more people in charge of quality than ever before. So why is that? Well, here's think of an analogy. If you look online right now, there's a lot of tools out there that can help you become a Hollywood mogul, right? You can literally make your own movie. So you can get a script and you can say, make a movie from this script. And you've seen some of them online. There was the famous one, I think, with a guy with a balloon head, where it literally made a video from a series of prompts and scripts using a generation tools. And of course, you can separately create a script using ChatGPT and say, write me a script for a horror movie that involves people from the United Kingdom in the year 1925 with this kind of plot line, and it will build a script for you. Now, will it be the best script? Not necessarily. Will the movie be a great movie that people want to watch and sells lots of tickets, or is on streaming services? Maybe not. So the question is, you can make a script, you can make a movie, but will it be compelling? Will it be exciting? Will it meet the needs of the person who commissioned it? Maybe not. And will it actually look right? Maybe not also. So when we think about software, it's exactly the same. You might be able to use AI to help you build a piece of software. Will it be usable? AI can help with monitoring and reviewing, but your job as a tester will be looking at that piece of software, making sure it's fit for purpose as well as functionally working. And so the example in the movies was not only did they find that using AI and types of technology and CGI, you end up making more complex movies, but there's a need to check things. First of all, to make sure that the actual movie is good and people will enjoy watching it. But even the very basics, like to make sure there aren't things that are unintended in the movie, will need to be done. So in the movie context, this is an interesting example that we all remember, or maybe remember, in Game of Thrones, set in the fictitious Westeros, in a sort of middle-aged type environment. There's a Starbucks coffee cup that clearly on camera, and someone didn't see it. Obviously, it got missed out, and not very in canonical with the movie setting. Imagine that's in software, right? We release software, and something gets into it that the AI didn't understand. Who's checking that? Who's making sure that doesn't happen? Testers, quality engineers, people who care about quality need to make sure that doesn't happen. In this case, it was funny, but imagine this was a mission critical IT system, not a movie, and something like that happened. People's lives could be at risk. Systems could go down. So it's really important to think about quality and checking is more important than ever before. Now, how does AI and machine learning help testing? So we've talked a little bit about how it's going to change the industry and the economy and also the types of jobs people will have. Now, the first thing is machine learning has already been helping testing. There are many tools on the market that help you improve the maintenance of testing. So when you write to automated tests, one of the challenges we all know is that you change the application slightly and the application breaks, or the test breaks rather, because it doesn't look like the old application, which is subtly different. So the brittleness of tests, AI and machine learning is already helping to make automated tests more reliable, more heuristic, and less susceptible to a small application change breaking all the tests. Second thing is machine learning and AI is really good at understanding large amounts of data. And so if you look at testing patterns, we can try and identify what trends we see and what future risks there might be. And I'll talk more about this in some later slides. In the security space, security has a massive impact with AI. AI is being used right now to create adaptive malware. It's also being used to create adaptive defensive tools. So on the offensive and defensive side, AI is being used heavily on the security infosec side of testing. So, for example, there's some malware now that you can unhopefully download that will, if it downloads, it looks benign. And as soon as it's downloaded, it goes out to OpenAI and asks AI to rewrite itself to meet certain criteria. And the reason it does that is because it doesn't write the same code every time, because it's fuzzy. It's very hard for security tools to pick it out because it doesn't look the same every time, and the actual implementation code will be different every time. That's kind of crazy. So self-learning, self-writing malware, kind of scary. There's another example where ChatGPT was used to automate social engineering, generate prompts that people think it's their boss who's emailing them or texting them, and then they end up giving away information they shouldn't. There's even a case of a video call where a video call was all fictitious. Every single person on the video call was AI generated except for the person who'd been invited to the call. It was with a bank, and they were asked to move $1 million to a different bank account, which they did because they thought their CEO was authorizing it. Turns out that no one in that room, in that video call, on a Zoom call, was actually a real person, which is scary. The idea of what is truth is hard to define, right? What's true, what's not true. And then the other problem we're seeing is when it comes to testing, making things much more difficult is what are requirements? What is the right result? So in a classic software system, you define requirements or user stories and use cases in BDD, and you will define that. You have code written, you have tests, automated manual. And the idea is to make sure that whatever the system is meant to do, the test verify, and that it has performance and it has security and all these other non-functional factors. But when it comes to self-learning systems, what is the right answer? If a system learns from training data and performs a beneficial outcome that isn't what we intended, but is beneficial, is that a pass? Is that a fail? That's a good question. I don't know the answer. Maybe you don't, that's something to think about though. What is pass? What is fail? It becomes a less binary decision. The other thing is that sometimes systems will learn and we won't understand how they've learned because there's no interpretability. A classic example there was a use case where they wrote a software program that could look at MRI scans and it would attempt to determine if the person had a tumor or not, if it was benign or cancerous. And they used some real MRI scans as training data, and the system learned from those and was able, with a very high degree of accuracy, with the training data, to predict. They gave it real data and it was useless. 0% of the time was accurate. and they had no idea why. And as a tester, you're like, why does the software work in development, doesn't work in production? Normally, you'd find some easy answer. It took a long time. What they found out was the system that had been trained was using MRI scans that had been done before by doctors. Doctors would write initials on the side to indicate their diagnosis, but people didn't realize that. And so the AI had simply learned to interpret the doctor's notes. Once they were trying MRIs that had no doctor's notes, the system had no frame of reference, but they didn't realize. So the danger is system is learning, but do you know what it's learning? Yes, no, maybe. So that makes testing more difficult. So that's a little bit of an overview of, I think, some of the benefits, challenges that AI and machine learning is bringing to the testing domain and the software development domain. Now, in terms of what we're offering at Inflectra, we've got two main categories: the things that are live today and the things that are coming. So if you are an Inflectra customer today, this first section you already have access to. So you may need to upgrade to the latest version, but you have access to this functionality already today, and you could or should be using it. So first of all, for those who are not familiar with our product suite, we have several products on our portfolio. I'm going to be focusing on two main product families today. The Spira family, that's the one in the middle with the orange, Spira Test, Spira Team, and Spira Plan. That's the functionality for requirements and test management, application lifecycle management, project and program management, manages the software development and software testing lifecycle. The second product I'll be looking at is Rapise in the bottom in purple. That's our test automation tool. We have AI functionality in both products, both coming and here today. So with that, let's talk about Spira first. That's, again, the middle three, Spira Test Team and Plan. With the functionality we have today consists of, right now, our Spira app. And Spira apps is our platform for writing plugins. So we've developed some AI plugins using Spira apps. Spira apps is an open framework that you can use to create your own applications. So if there are some use cases you're interested in including AI in the application that we haven't thought of, or you want to just try out yourself, you can use our new third-party development tools to actually build your own Spira apps inside of Spira. But the functionality we have today that's live is our ChatGPT plugin. It's basically OpenAI, not really ChatGPT, but people know that, so it's got a higher brand recognition. So we call it ChatGPT. This lets you generate downstream artifacts from requirements. So if you take a user story or requirements like we have here, the ability to log into an application, you can use it to generate test cases, tasks, scenarios, and risks. And for those customers that are in a highly regulated industry or in a high assurance industry, there's also a second version we have, which is based on the Azure OpenAI platform. It's the same functionality. The difference is with ChatGPT, you're using the public OpenAI model. And under the OpenAI terms and conditions, they do not use anything you're putting into Spira and sending to this as training data, but it is going out to their public API. And I believe they do retain it in their session for a period of days, but it doesn't train the model. So for most customers, that's going to be fine. But for those customers that really don't want any data leaving their environment, if you're a Microsoft Azure customer, you can enable Azure OpenAI, so it's a mouthful, and that lets you do the exact same thing, but the data now never leaves your Azure environment. Okay, now let's have a look at that in live, because again, PowerPoint is all well and great, but it's nice to be able to see things live in the application. So let's go ahead and do that. So here's our website. Let me just hide the meeting controls, and over here is Spira. So this is how you would use the functionality. So just to show you a little bit ahead of time of the setup. So in Spira, we use what are called Spira apps, which is our plugin framework. And in Spira apps, you enable the functionality. So if I go over here, there's the ChatGPT application. It's been enabled on my instance. If I click on the settings, there's a bunch of settings lower down. You don't need to change, basically. But the two at the top might be interesting is the temperature is the first one and the model. The temperature is used to control the randomness of the output. And so when we see the functionality, I'll talk about why you might change that. We're using a low number, 0.2, and it's the default. That gives you highly deterministic output, but less creative and random. And then the second one we're using the GPT 3.5 turbo model. Now that's one of the older models from OpenAI. The reason we do that is it's cheaper and faster. And for many use cases, it will be sufficient. The main limitation of 3.5 turbo is it doesn't have access to the last 2 years of data on the internet. So it's giving you more historical information. So if you're working on an application in a domain that's well understood, I'm going to show you an example of booking a hotel room. That's a well understood business problem, and you don't necessarily need the latest and greatest information from the internet to do that. 3.5 will be cheaper. If, on the other hand, you're building a very innovative application, an IoT device or a self-driving car, and you need much more up-to-date information, you might want to change it to the GPT 4.0, 4.5, or one of the newer models. But it gives you that flexibility on a per project basis to specify which model and which temperature do I want to use. Okay, that's a little bit advanced. So let's come back into the basics. So I'm going to go into Spira and I'm going to go to the requirements module. And I want to create a new requirement and I want to generate tasks and test cases from that. So it's super easy. You go in and you check a box and you say insert and let's go ahead and write my requirement. And I'll do it in a user story format, which is as a customer, I want to be able to book, you see I've done it here before, book a hotel room. Like that, okay? That's my requirement. Click on it. And I want AI to help me. Now, without AI, what I would do normally manually is I would go into test coverage and I would say, let's create a test case, booking a hotel room. I want to book a hotel room maybe for one night, for multiple nights, whatever it is, all the different test cases. I might decide to write some development tasks, write the screens, develop the algorithms, integrate with the back office, whatever it is, write some tasks. And maybe I've got some risks I've defined that can link my risks. And I might want to write some BDD scenarios. So to do that, I might change it to a use case. And I might want to write some scenarios, and then these would be down here as well. So there's lots of things I would normally do, but let's see how AI can make that much faster. So instead of doing all that manual work, I can go to ChatGPT right now and I can say, generate test cases. And one thing I'll mention is AI is inherently random and interesting. That means sometimes it will send back data that's not appropriate. Our system will attempt to read the data we get back and interpret that appropriately. In this case, it was able to do that, and it will tell us how many tokens it used. If it isn't able to do that, it will give us a warning and tell us to retry. You might see that on this demo, pending. Okay, we'll come back to that. Let's think about development tasks. Let's get our developers busy. They're lazy. They should be busy. Just kidding. Let's get them going. Okay, okay. They did that too. Again, how many tokens it used. Let's go ahead and generate some BDD scenarios. For those who are into Gherkin, I Gherkin in my sandwiches and Gherkin in my test cases. So, yep, BDD, good to go. And lastly, do some risks. Okay, it worked every time. Interesting. The webinar last night I did, one of them didn't work, and then it worked from the retry. So sometimes it will do that. Again, if you play around with it in our system, you'll see it gives you interesting results. So let's go look at test coverage first. It's a tester. So hit refresh. Oh, hopefully, I've got some test cases. Let's see. There we go. I've got 1, 2, 3, 5 test cases. So first of all, I've got the attempt to book a hotel room with a valid input, attempt to book a hotel room with invalid number of guests, exceeding the maximum capacity of the room. Maybe the hotel name is missing. Maybe the check-in date's missing. Maybe the checkout date's before the check-in date. Let's look at one of these. And it will tell you right here. Attempt to book a hotel room with invalid number of guests exceeding the capacity. And the sample data is Mountain Lodge check-in date, number of guests 10. So it's giving us some sample data. Wow, that's pretty cool. And if I do the same thing, if I go to some of the other ones, if I go back to my requirement, let's look at missing check-in date or like that, and I'll do valid input. Let's look at a couple of these. You can see here's a different one. Hotel name is City Center Hotel. Checkout date is 23/08/20. One guest. And this one is the one that I think worked. So then we've got valid sample data, luxury hotel, check-in date, checkout date, number of guests 2. So it's given us some sample data. So that's pretty cool. So it's given us 3 test cases, and there's obviously 2 more I didn't look at, but are there. So those test cases are pretty useful. Well, let's go look at the scenarios. Down here, it's given me the 3 BDD scenarios. The first one is given when then, given the customers on the hotel booking page, when the customer selects the dates and the room type, this displays a confirmation message. If they try and do the same thing, but without providing personal information, gives them an error message saying they need to put more information in. If they select dates that are not available, it gives them unavailability. So we've got 3 different scenarios here, and we've got test cases. So we could use those to generate more test cases. So that's really helpful. If we go to the task section and refresh, it's even given us some more development tasks, create a confirmation email, develop a booking system, create a UI, implement a notification system. So that's some tasks we would have to carry out. And the last thing it will do is identify all the risks that could be relevant for this kind of application. So performance, It could be incomplete information sent to the booking system, data loss if the backup and recovery, integration with the booking systems, security breaches because you've got a lot of personal information, poor user experience, scalability, and maybe we should look at other booking platforms that might be better than us. They already exist. So it's given us a mixture of business and technical risks. And some of that's because we put in the system certain prompts that we've defined and honed to give you that functionality. Now, before we go any further, the question people would ask me is, well, that's well and good, but I could have done that. I mean, nothing there is earth-shattering. And that's a really good question. So I asked our head of QA, Kevin, what do you think of this functionality? And he said, apart from I want it now, which was a good answer. So we gave it to him. The other thing he said was, it's interesting. In many of these things, if you look at the test cases, for example, I mean, I think, and I'm thinking about it myself. He said, I thought of some of these, like valid input, yeah, you can't have the hotel and everything. Check-in date couldn't be before the checkout, after the checkout date, sure. But I wouldn't have necessarily thought intuitively about number of people in the room, maybe not right away. And he said that was the interesting thing. And if you look at some of the other scenarios, maybe the risks or the tasks, some of those might be not relevant. So you delete them. But it's still quicker to generate 5 or 6 or 10 things, delete 1 or 2, than it is to write all 10. It's also interesting if it comes up with something you didn't think of. So there's 2 aspects. One is it will find things that you thought of and saves you time. The second thing it will do is it might find 1 or 2 things that you didn't think of that would have tripped you up later. And so it reduces your risk. Now let's go back to that temperature setting that I mentioned earlier. I'm using it in a very deterministic mode. I'm using a low temperature. That means the AI is not going crazy. It's like find things that are realistic. Now, so that gives me almost my happy path and my kind of like base case. But imagine I change the temperature, and I go back and I hit that same button 4 times for those exact same 4 things on the same requirement with a really high temperature setting. I won't do it right now, but I might try afterwards. It will give you much more random output. You can't book a hotel that doesn't exist yet. Maybe that's it. So, for example, but you might come across a use case that will be useful. So again, you can play around with the temperature settings to increase the randomness to get more interesting and potentially more edge case examples. But the key is it does 2 things for you. 1, it simplifies and speeds up the existing work you do. And 2, it finds things that you didn't think of and reduces your risk. So that's kind of I think the 2 takeaways I would say. It doesn't replace people doing this stuff. You're still going to have to read these requirements and test cases. You're still going to have to edit them, but it speeds things up and it reduces risk, doesn't eliminate risk, reduces risk by finding examples of things you wouldn't have thought of. Okay, let's go back to the good old PowerPoint. So hold on, go back into SlideShare. Okay, so moving on from that, let's look at some other functionality that we do have already available today. And there's already a live video on this. We did a webinar on InflectraCON, I think a few weeks ago. So hopefully you've already seen this. But for those who were on that webinar, we've partnered with a company called Angulon AI, and their product's called Eoten. And it's a tool that integrates with Spira, and it scans your code base for changes. And based on the change in your code base, it will suggest which test cases you should run. So imagine you've got a CI pipeline and you've got 100 test cases and it takes a while to run. Wouldn't you want to know which of those 100 that you need to run every single CI? Maybe some you could push only into later phases, so you can reduce the amount of tests you're doing randomly, just to focus on the risk. We change this line of code. We know that line of code based on historical analysis will break these tests or impact these tests. Let's run these ones. We know this line of code change isn't tested by these parts of the system, so let's not run these other tests. And for manual tests or longer tests, that can even be more useful. And so it's a really good tool to optimize what you're testing. And Eoten has a second feature, is that it can look at your historical test cases and flag for you which of the tests are potentially flaky tests that you should look at improving. So it finds which tests to run and which tests need to be improved. So it's a pretty good tool. And this is using the data you have in the system and analyzing that. And the third AI feature we have in Spira is from another partner of ours, Essence AI. It's a code assistant. It lives inside of Spira. It's also inside of other tools like Visual Studio. And the benefit of this is, let's say you've got a large team that you're scaling up doing development. And let's imagine that you've got that new team members or new team, and they're looking at code that someone else on the team wrote, or maybe a different team wrote, if maybe you're transitioning to the code base. Either way, they look at some function. What does it do? Why was it written this way? What are all the dependencies? That's one of the hardest things about giving someone a code base. Sometimes people say it's easier to write code from scratch than to inherit someone else's code base. But obviously, we're dealing with existing code and legacy code that's written. That's not always practical. So with Essence AI, it's a live assistant that basically helps you understand what the code is that you're doing, that you've inherited is doing. So particularly when you're working with someone else's code that you're enhancing or maintaining, it's a really good way to help improve the understandability of the code that you're doing. And obviously, if you're writing code, it helps you do that as well for other people. Now, jumping then across onto the Rapise side of things on test automation, our Rapise product in its current version has some limited self-healing functionality. We've got some new stuff coming, which I'm going to show you next, which is really exciting. But in Rapise, the self-healing functionality for the web tests, it will scan multiple locators that you can see here. And when you run a test, it will look at the multiple locators and attempt to verify, is a change in the application a breaking change, or is it a change that's actually due to a failure? So, for example, let's say we've got a username field. You can see here in the example on the bottom left, and it was user space name, and now we've changed it to user without a space, username, or the reverse. And typically in a test automation test, depending on what you changed, that could be a fail. Or maybe the label is still the same, user space name, but we changed it from a div to a span, or we changed the CSS class on it, or maybe its ID changed, depending what's in there. As you can see here, it's applying multiple different attributes to locate that particular item. And it looks at what changed historically, and determines what's the probability that what we have found is the same thing and is therefore a pass, or what's the likelihood it's not findable, we've broken the application, or something's different that's breaking, and it's a fail. So in this case, it's telling us that it thinks it's a pass, 94%. So it's going from this whole binary, the application is 100% identical and it's a pass, or it's 100% not identical, it's a fail, to be this application is not identical, but we still believe it's a pass, and here's why. Do you agree or not? So again, making testing more heuristic. As a tester, instead of writing locators yourself and going to F12 and grabbing XPath or CSS and doing all this manual work, instead you're applying heuristics and saying, the tool tells me it thinks this is a pass or a fail. Let me check that, check that, check that. Do I agree or not? How do I improve the model? So that's again where AI is taking us. Now that's available today. Now what's coming in the future? Aha, the future, the undiscovered country. So first of all, let's look at Spira. On the Spira side of things, we've already shown you the ChatGPT integration. We've shown you the fact that it can generate downstream artifacts from a requirement. The first enhancement we want to look at is how we generate better and more tailored artifacts. What I mean by that is it generated, I think in this example, 5 test cases and a similar number of risks and a similar number of BDD scenarios and a similar number of development tasks. So each of those in Spira, we do have more information than we've used. Well, right now, we're only using the name of the requirement. What if we use additional fields? And so the idea is letting users customize which fields get sent to the LLM, the name, the description, maybe a custom field, maybe a notes field, maybe a standard field, and building the prompts to adapt to which fields are used. The second thing would be if I've defined different types of test case. I've got a functional test, security test, performance tests. I can loop through all of those different types, the metadata in Spira, and have separate prompts for each one. So instead of getting back, 5 test cases, if I've got 10 different test case types, I might get back 50 test cases, 5 for each type, which will give you much more information. Now that probably means there's more noise, which you'll delete, but there's also likely to be more test cases that are valid. And more importantly, there's probably more test cases that are going to find things that you would have missed. Same thing with risks, same thing with tasks. Another thing is, how can we have that functionality and use it to write test steps? So taking it to a manual test case and generating all the manual steps from a single line, we can do that as well. And then other functionality would be around from a usability standpoint is how can we do it on the grid so you can check multiple requirements and say generate test cases for all of these. So there's lots of different improvements to make what we have today better, more usable, faster, give you more information, more customizable. Absolutely. And then some other use cases beyond just improving the current one would be if you go into the requirements backlog view, the grids or the boards, or even the mind map view, going into there and choosing a node of a requirement, saying, I've got this user story or a feature or an epic, particularly a feature or epic, and say, generate all the user stories for this epic. My epic is hotel reservations. Generate all my user stories. It could do that. I mean, it would understand how it can generate that very easily. Now, it won't think of every single part of hotel reservations, but it will think of most of it, and it will save you a lot of time. And then the other natural level beyond that is if you go to the highest level is define the project scope. I'm building a new hospitality application that's going to do these 5 things. That becomes your project description. Generate my entire project for me. Generate all my requirements. For each requirement, generate all my test cases. So you think about it. You start with one paragraph, click one button, walk away, get a cup of coffee, come back, and it's built up the entire Spire project for you. That's not unfeasible. And then the last thing, so then the next thing in terms of the more technical side of things would be, we're doing it right now. Yeah, you should be scared or worried. I don't know. Um, the other thing would be, what about using other models? Because this comes up a lot. People say, why are you using OpenAI? We're using OpenAI because it's very easy to prototype with. It's really easy to build with. They've got a very easy to access API. We're looking at using other models, and particularly things on the AWS Bedrock platform. As you probably know, Spira and our platform is powered by AWS. And AWS Bedrock has a bunch of other models like Claude, Llama, and Mistral, plus others available. And so the idea is once we've got this functionality working with OpenAI's GPT models, we will migrate the functionality to other models. And the benefit for that would be if you want to use running models that maybe you host or we host and they're more private, or they're optimized for different types of application, you have the best of breed. You haven't got to just be limited to what GPT-4 can do or GPT, version X. You can take the best of breed approach and use different LLMs, which may be suited to different types of application. And then the next piece would be, which you can see here, is how do we use the data in Spira? Right now, we're actually sending very limited data. We're sending the requirement name. We talked about sending like descriptions and other fields. What about all the relationships? Spira has a wealth of amazing data in it. It's got traceability data between requirements to test cases to code. And some of that we're using with Eoten. When Eoten generates the list of tests that are impacted by code, it's using our link between data in Spira and the code repositories. But imagine we take that one level further. Look at all the data we have in Spira, send that into an LLM and say, take all this unstructured data, find issues, find risks, determine what we should be worried about. The problem would be something like, as a project manager working on a mission critical application where I'm running short of time, on this project, which currently looks like this, what would you be worried about? So again, using AI to suggest things and find things in the unstructured data that we have, as well as the structured data we have, is very powerful. Now, the limitations right now are that means using other techniques called RAG, retrieval augmented generation, where we send data into a pre-trained model, or using vector databases. It's complicated and it can be expensive still. But as the computing power is becoming more effective and cost effective and economical, and as these models become more powerful and more economical, it will become more feasible. So right now, some of the limits would be speed and cost. Sending lots and lots of data to a model, an LLM, can be expensive. So that's why we've written our current plugins the way they are, where we're mostly sending small bursts of data and getting data back. That way it's quite inexpensive. Now, on the automation side, we've got a lot of things planned too. And here's a screenshot, first of all. So this is functionality coming out in Rapise 8.1, which I've been informed reliably is coming out at the end of June. So that's 6 weeks away. So the next 6 weeks, more or less, you will have this functionality in your hands. And this will allow you to do a lot of things that today would have seemed like science fiction a few months ago. So what you can do is define different workflows. These are basically effectively agents in the system that can help you. And we've pre-built some default ones. We've got some that will generate test data, some that will write automation scripts from manual test cases. We've got ones that will help you from a general kind of assistant chat. And you can write your own as well using that new workflow button. But let's look at some of the ones that are going to come built in and pre-shipped. The first one is this one here. This lets you interactively work with our assistant and say, I want to do certain things, tell me how to do it. And you can see here, I wanted to log in as a librarian into our fake application, and I want to be able to click on a link, create a new book, and log out. And that would require me right now in a traditional model, either going into the application, recording the clicks, or it would require me learning all the objects and then assembling the test scenario. Instead, I'm able to interact with it in natural language, and it tells you what to do. So hold that for a second. This is the application we're talking about, by the way. It's called Library Information System. It's on our website, and I'm just telling you to log in as that library user, log in as a password librarian, click on the books link, which is under book management, create a new book that you can see there, and then log out. Now, and you can also tell it to create a book, put these names in, and do a lot more as well. So how does that work? Well, that's basically taking a manual test and automating it. So this is how it would look in practice. We've got the exact same prompt, actually it's a slightly different one. Log in as librarian, log in as librarian 123, wait 5 seconds, log out, or it could be the previous one. It gives you back, as you can see in the black square, the sample steps, and then you can hit the apply button or edit and apply, and it applies it into Rapise. So you've taken a manual test and turned it into an automation script right there. Can we go back again? You can do the exact same thing with this one as well. Log in librarian, click on books link, create new book, hit apply, and that would also appear in the grid. So that takes a manual test case and automates it. Now, the second thing you could do is, let's say I don't necessarily want to have all the script stored. I want to use the manual test case as my source of truth. We can do that as well. In that case, instead of it having generating script, what it's doing is I can actually write my test, as you can see here, rather than being interactive in the console, I can actually write in my test the AI steps. So we've got this new type of object called AI, and you tell it what the objects, what the steps are in natural language. You can see that under the object field in row 3. Log in as librarian, click on the books link, click create new book, and log out. It takes that information. It takes the list of objects that it's already learned from the system and the functions they expose. So it knows that a button has a click option. It knows that a text box is an entry button, for example, or things like that. And it will generate automatically the test and run it for you. So now you've got the ability to take a manual scenario that can either be written directly in Rapise, or it can be written in Spira and then automatically appears in Rapise. And now you can automate it using AI. And it does that using the objects that it already identified. So that's super cool. The other thing it can do, imagine you've got a situation where you've got a testing team that's not doesn't have a lot of automation engineers, more functional testers. And you can use the codeless interface in Rapise, looks like that, or like that, to write the tests. But suppose they come across a situation where they need someone to write something that's more techy, like I want to be able to generate some data, or I want to be able to, make dates or verify dates, things that are programming techniques. Traditionally, you have to ask your programming friends to do that for you, wrap it in a function, and then your codeless part of Rapise could then call that function. But suppose your programming friend is on vacation or busy or doesn't like you anymore, or you've run out of pizza to feed them. Don't worry, don't need that anymore. You've got your AI assistant to do it for you. So you can save on pizza and you can have this instead. So what you do is you would say, I really want a JavaScript function that returns the name of the current day of the week because I need that. And my codeless test works perfectly fine otherwise, but I really would like to know the current day of the week so I can send that in as test data. And I could go to Stack Overflow and I could find a function that does that, sure. But this is better. I type it in, writes the function, and I hit the button and it now says, hey, there's my function. And now I can call it from my codeless interface and use it in my test script. Fantastic. Now, another situation is, remember the library information system project? When we first built library information system, we loaded it with about 14 books and 3 logins, and that was about it. We've actually built some new versions of that to allow people to try out Rapise testing different kinds of application like Flutter and Angular and React. And every one of those samples is a different version of the application. And they all needed test data to make the application realistic and be useful from a demo or a POC standpoint. And so we need to generate test data. And traditionally, we would make it up in Excel, or we go online and scrape it from a source. And for books and things, it's probably okay because it's not publicly sensitive. But imagine you've got to create test data that's sensitive. That could be harder. So the great thing is now you can say, generate 10 fake company names, and it will do it for you. Okay, there's my 10 companies. That's nice. And it appears automatically in my Rapise map. That's my data entry screen. And that's going to be used now to loop through my tests. And I can then run through a list of tests with, like, it's imagine an ERP system. It's a ServiceNow, or it's a Dynamics, or a Salesforce, or Oracle, SAP. And I'm going to create a purchase order for 10 different companies. I need 10 company names. I've now got them. Maybe I need purchase order numbers. Same thing. But then I say, well, those 10 companies are pretty good. But what if I want 10 more? I can, rather than to go say, I need 10 more company names, I can just say, it's interactive. Just give me 10 more. And it will know I need 10 more. And actually, you can do even more cool things. Like you might say, well, those are really good, but they're pretty clean. How about I want 10 more, but I want them all to have foreign characters using high ASCII, or I want them in Chinese or Korean, or something that, or a left to right, an Arabic, a right to left language. I want to train different kinds of test data. Or you might say, give me 10 more rows, but I want all of them to be over 500 characters because that's going to break the system or might break the system. So you can tailor your test data to hit some of the exception cases. So you can now got data as code on demand. Pretty cool. Other possibilities. Okay. So before I get to other possibilities, everything I've talked about up to this point is either live today or coming out in the next few months. So near term. What about further term? So things that are not coming out in June. So this is not coming out in June. This is the future stuff. Well, one thing is visual testing. Now, there are tools that do this already today, but they're still flaky, unreliable, or very, very expensive. GPT-4 Vision is going to democratize visual testing. Why is visual testing a good thing? Well, first of all, many of us know we have to test applications that you can't connect to. So you're using Citrix. You can't test a Citrix application very easily with Rapise or other tools because the application isn't actually there. Or you're testing a mapping application, something that's geospatial, things that are hard to test with traditional automation tools, or it might be an application that's a traditional grid application, but it's a desktop app. It's not using a standard UI toolkit, so none of our tools can handle it. Most of our competitors can't handle it because it just wasn't worth building it. With visual testing, as long as you can see it, you can test it. And it turns out with GPT-4v, you can do that. So this is us giving GPT-4v one of our other versions of our library information system. This, I think, is the Angular version, or it might be the React version. We gave it the page and said, identify all the key objects on the page that are clickable. And it did that, and it tagged them. And from that, we can now build new locators. And instead of it being, look at the CSS or the XPath, and it's this or it's that, we can basically say, record a click against item 1, item 3, item 8, and store how you know how to find it. That certainly changes the game. We're now tagging things visually and using it in a test script. Opens up a whole bunch of applications to be testable. Now, why aren't we doing this tomorrow? The question is the problem. Right now, if you use this today on GPT-4v, it does work some of the time. It's not reliable. It's flaky. So we've been experimenting with it and prototyping with it, and it's super cool, but it's not quite yet ready for prime time. It's not reliable enough yet. Now we're trying different prompts. We're seeing the model is improve over time. And definitely we think within probably this calendar year, maybe early next year, this will be ready for prime time. But that will change testing for a lot of applications. It will change how we think about testing. We're starting to see applications and GPT flavors that can even do exploratory testing. You can say, go through this application and click through these screens and record what you see and tell us what you found. Very unstructured, but it can do that. It can return back and give you a series of screenshots or a video clip and give you insights. So we're heading into a world where testers will be reviewing videos, reviewing screens, training it, not necessarily writing click-by-click test cases. We're heading in that direction, but this will be the next step. So with that, I've talked about a lot of things, both near-term, future-term, and some general trends. Rick, what questions do we have, if any?
We don't have any questions at this point, Adam, but I did have you shared a link about the EOTN AI.
Yes.
Can you grab that link and text and put it in the chat window here? So I think people would be kind of interested in that. I thought that was really, really neat as well.
Let me go
back a little ways.
I think it's this one here. Yeah, there it is.
There it is. Yep.
I think I have to exit. I'm going to exit slideshare.
Yeah, there we go.
Oops. And I'm going to grab that and I'll put it in the chat window for everyone. I want everyone to see it. So host, panelists, everyone. Oh, there we go.
Yeah.
Right there. Thanks.
Thank you. That's perfect. Okay. It looks like I have a question here. Rapise uses GTP4 only with
RVL,
or can we use it in expert mode too?
Great question. I only took some screenshots. Well, actually, I asked our automation team to give me the screenshots. So I chose the RVL example. GPT-4, GPT-4 for Rapise. It can generate test scripts in both RVL format or direct JavaScript format. Either is fine. I will just go to the website of our company. You go there and close that. You go to InflectraCON. This is the InflectraCON 360 website. All of the webinars and other panels will be here. In fact, here's today's featured event. And you can see the previous events we have listed here, including the EOTN event and others as well. There's the EOTN event right there. We've also got one about model-based testing. We've got some other videos and sessions coming up. This is our global hub for thought leadership and panel interviews, webinars, everything to do with the industry. This is just, again, for the 1st of May chat, so we have our AI. It is a very important topic.
That's all the questions we have for now.
Okay.
I appreciate everybody being with us today. I thought it was very informative, and we have a lot more webinars coming up. Be sure to make sure you check out the InflectraCON 360 at inflectracon.com. There's lots of great events coming up in the future. And also follow us on LinkedIn. We've got all kinds of announcements coming out on a regular basis on LinkedIn. Great articles, great information, and announcements for awesome webinars just like this one. So Adam, appreciate it.
Thank you. Thanks, Rick. Thanks for being here. Have a great rest of the day, everyone, and look forward to see you on a future InflectraCON webinar.
Bye-bye.